Okay, welcome to the first video of Algebra 1 for this year. I hope that you have your note packets out, and we're starting on page number 2 of your Unit 1 note packet. And we're going to go through, and as we go through, I expect you to follow along in your note packets here and make sure that you get everything down in there. And once we're finished watching the video, click to continue into Schoology and write the 2-sentence summary using a vocabulary from the video on what you've learned. So we'll begin. Our goal today on the first day is to evaluate variable expressions, understand the mathematical meaning of verbal phrases, and use verbal phrases to write variable expressions. For example, blue whales get about 4 tons of food per day, so that's quite a bit of food. It's almost as much as I eat, but not quite as much. To find out how many tons of food a blue whale eats in a given number of days, you could just multiply by 4 for the day. So for example, in day 1, you'll see that 4 times 1, that's 4 tons of food. So on the first day, they eat 4 tons. All right, if it's been 2 days then, you'd expect that on the second day, you multiply 4 times 2, and now in the 2 days, they've eaten 8 tons, and you could see how this can keep going. After 10 days, they've eaten 40 tons, and just for any day, D, all right, this D is going to be a variable, and we're going to define that on the next page, but that is a variable quantity, which means that we don't know how many days it's been if I just use the letter D. But the expression then becomes 4 times D. These are all examples of numerical and variable expressions. So for example, these first 3 items that we did, the first 3 calculations that I did, let's get my highlighter here, that's what I'm looking for. 4 times 1, 4 times 2, and 4 times 10, those are all numerical expressions. Those are all numerical expressions. And numerical expressions are just numbers and operations together. And if you don't know what the word operation means, operation is just multiplying, adding, subtracting, or dividing. It's those 4 operations that we know. And sometimes other operations too, like exponents, and radicals and everything else too. So it's just the 4 math operations that we do. A variable is a number whose value is not known. It is just one number, but it is a number whose value is not known. And we can give a variable a value, and we'll get to that in the next page, but for right now, it's just one number that we don't know. And a variable expression, you can imagine, is an expression of numbers, variables, and operations. So an example of a variable expression is this very last one right here. That is a variable expression because not only does it have a number and an operation to make a numerical expression, but it also has that D value there. So that is a variable expression because it has a variable inside of it. So very similar ideas, and just one has a variable and one does not. And here's what I was talking about in the last slide. If I want to evaluate a variable expression, evaluate is to use a number to substitute for a variable. And the word, I spelled substitute wrong. Sorry about that, I must have been in a hurry. Let's respell that. The word substitute, that means to put in place, just like you would in a sport substitute a player for another player, that is to replace. Okay, and typically they're equal. Whatever you put in the place for the variable is what that variable now is. They're equal. It's sort of like if you play soccer, you'd put a goalie in a goalie spot. You would not put a forward or a defender in a goalie spot. You always put the goalie in there. They need to be the same thing. Example 1. We can evaluate the expression 4 times D when D equals 120 to find out how many tons of food a blue whale eats in feeding 120 days. So remember, it was 4 tons each day. So what I'm going to do is take my variable expression and I'm going to evaluate by substituting the value for D. So instead of having a D, I'm going to plug in or substitute, replace with 120. I let D be equal to 120. This is like a goalie and a goalie. They're the same thing. I just substitute that 120 in for D. Now I will perform the operation because I want to actually know how many tons it is. So I'm going to multiply that by 4. 4 times 120 is 480. So the answer is about 480 tons of food. That's how much a whale will eat in 120 days, considering they have 4 tons times the number of days. All right, let's do a couple more examples. So let's say we want to evaluate these variable expressions when x variable is 10 and the y variable is 4. This becomes just as easy as just using substitution. So for the x, I'm going to put a 10. And for the y, I'm going to put a 4. And the operation between those two numbers, those two variable quantities, was addition. So 10 plus 4, that will be 14. It is that easy. I'm using the language here, though, to explain what I'm doing mathematically. I am evaluating by using substitution. I'm substituting the value of 10 in for x, and I'm substituting the value 4 in for y. Now, it's important to note here that these two variables, x and y, are kind of saddled next to each other. They're really close and touching. If you see that, that means that they are being multiplied together. And notice for multiplication, I don't use an x anymore. I use that dot, just like we did in the last slide. I multiply 10 times 4 and I get 40. And that's the value of the variable expression x times y when x is 10 and y is 4. A verbal model. If you don't understand what that means right away, let's look at the term itself and see if we can figure out what it means before I give you the definition. What does it mean to be verbal? Verbal means to speak or to say something, right? So speaking or maybe just to say it out loud. And model means to just represent. So speak and then models represent. And that's pretty close to what the definition of this mathematically is. The definition of a verbal model, though, is writing variable expressions from words. Now, obviously, I communicate with you right now by speaking, but if I can't speak, the other way you could communicate with words is to write down. So there are words that basically represent the different operations. So for example, the operation of addition or adding, you could see it plussing, finding the sum, something being increased by, totaling something. If I want to find out how much I had to spend in total, I would have to add up all the prices of what I was buying. If I say I want 6 more than what I have, I must add 6 to what I have. Added to is another way to say that. And I won't go through and read all of these, but this table in your note packet should be pretty helpful. Okay, so you might want to put a bookmark in here and just refer back to page 4 whenever you need to, just to find those words that indicate operation. Now be careful. Order is important in subtraction and division. So if you see the words, the difference of a number and 7, that means that the number n has to come first and then put 7 second, not 7 minus n. The same thing goes true when you're dividing. The word quotient indicates division, and the phrase or the verbal model, the quotient of a number in 5 is n over 5, where a number is that variable n, and 5 is the thing that you're dividing by, the divisor. All right, so for example, let's say you plan to divide 120 players in a baseball league into teams with the same number of players. Let's use a verbal model to write a variable expression for the number of teams if you know the number of players on a team. So, for example, I have 120 players, and I want to divide them into the same number of players. Let's say I haven't chosen how many I want to be on a team. And let's say for this example, you don't know how many people are on a baseball team. Well, we can use a variable to represent that number. Remember, a variable is just a number whose value we don't know. So number with unknown value. In this case, n is going to represent number of players on a team. Okay, so of course we don't know how many we want on a team, but once we find out, like let's say for example there are 10 players in each team, well that would make it easy because 120 people divided into 10 teams would make 12 people per team. But we don't know that 10 is the number that I want in a team. I evaluated by substituting 10, thinking that 10 might be the number on a team, but I don't know that for sure. There's nothing in this problem that says that there has to be 10 people on the baseball team. So for example, I will just put n because I don't know how many are supposed to be on there. That is the number of players per team. If you think about the units, this is 120 players, and n is the number of teams. So it's 120 players, and I guess this is the number of teams, I suppose. So when I divide those out, it's going to be players divided by players per team. And it gets kind of complicated there, but it'll end up being players multiplied by teams per player. Cross out, we'll get the number of teams. Okay? So that was more complicated than it had to be. Basically, all you need for this problem is just 120 over n. That is the expression I'm looking for. That will get me the number of players, or the number of teams, or the number of players per team. All right, thanks for watching the first video. I hope that you followed along in your note packet. Don't forget, once you're done watching this, to click next below and respond to my questions on Schoology. You have to write your summary in the little box that you'll see on the next screen, and I'll grade it from there. Let me know if you have questions. Feel free to message me on Schoology or to send me an email from my syllabus. And so, in case you don't have that in front of you, here's my email just in case. It's a very long one. It has C. Loveless, and it's that West Fargo domain there. So west-fargo.k12.nd.us. All right, thanks for watching. We'll see you tomorrow.